All right, so this week we are going to take a look at some of the topics we did again last week. There will not be any homework from the book. It's all going to be worksheets. So if you go to the review 4243 that says detailed, it has 3 different assignments in it. Each one is going to be for one of the days in class. So review 1 will be Tuesday night's homework. Review 2 is Wednesday. Review 3 is on Thursday. So we're going to start with review 1. Okay, I'll go over some questions from that. And then whatever time is left, you guys will have time to work on that review in class. So you might not have to do the whole review for homework. All right, so the first topic that we are going to review, these are littler topics that were on the test. So we're going to do 4 of them. How do you find roots? How do you find the EBM? How do you find the domain? And then how do you find local extrema? They're all relatively quick. That's why we're going to do a couple of each. Tomorrow, when we do the review, I think the topic we're doing is a little bit longer, so we're not going to do as many different things tomorrow. Okay. So let's start with finding the roots. Okay, so finding the roots means we're going to take that equation, solve for x. There's a couple ways we can do it. Some of the problems they say you can do algebraically. Other problems have you graph. All right, let's try this one algebraically. So when you have a fraction, doesn't matter what's in the top or in the bottom. If you have any fraction equal to 0, there's only one way that that can ever happen. What's the only way that you can divide 2 things and ever have the answer come out to 0? If they're the same, then the answer would come out to 1.
Oh, 0 then. 0 over 0.
0, well, you can never have what in the bottom?
0.
Yeah, so you can never have 0 in the bottom. So it's 0 on the top. Okay. So I'm just going to write down to solve. Set top equal to 0. That's how you find the roots. Set the top equal to 0. Right? And then check your answer. Check to make sure it works. Okay, so what's in the top of this fraction?
X squared minus 5x plus 6.
X squared minus 5x plus 6 equals 0. There's only one number that we're going to hope we don't get for the answer here. What number would be a problem to plug in for x in this whole thing? 2. Because if you plugged in 2 for x, what would that cause to happen? You'd get 0 in the bottom, and we can't have that. So the only number we hope we don't get is 2.
What happens if we do get 2?
If we do get 2, then we have to cross that out and say it's not the answer. Okay? So let's try this and see what happens. This is a quadratic. It's quadratic because the highest exponent is a 2. One way to solve a quadratic is the quadratic formula. I think that's too complicated for this one. What do you call it when you set up something like that? 2 sets of parentheses.
Factor.
Right, we're going to factor it. Okay, what would be my first thing that would go here and here? So when I multiply them together, I get x to the second.
Can you explain factoring a little bit?
Factoring?
Because I never understood it when I first went over it in like algebra 2, and that didn't help.
Okay. So the idea with factoring is you are finding 2 things you can multiply together to give you that. That's the goal. So we have to find 2 things that multiply together to give you that. The first thing you start with is you put something in this box and you put something in that box that multiply together to give you the first term. So what are 2 things you can multiply together to get x to the second?
X and X.
Right. So you're going to need an x and an x. Okay. The other thing with factoring is you have to put signs after each of these boxes. Your options are plus or minus. There's no guesswork. You can tell exactly what signs you need based on the original problem. So when you look at the original,
Do subtraction.
and then when we factor it, if the original problem, I call this one the middle, so that's middle. This one here is the constant. So we have middle and constant. There are 4 different cases that you can have. You can have a negative in the middle and a positive for the constant. That's what we have in this one. You could have a positive and a negative and a negative, or a positive and a positive. Those are the 4 different options you could have in the original problem. That's the original. So now, when we factor it, if you have a negative in the middle and a positive for the constant, the 2 signs that you need to use in the parentheses are a minus and a minus. In fact, if you want me to, I can write it. Let me write it that way. It's going to be x minus, x minus. If the middle one is a positive and the constant is a negative, then you're going to need an x plus and an x minus. If they are both minus, you're going to need, same thing. One's a plus, one's a minus. And if they're both plus, then when you factor, they're both plus. So there's a chart that shows you how to get the signs when you're factoring. Okay, so let's look at ours. In the original, what's the middle term?
Subtraction.
It's a subtraction. And what's the constant? Addition. That means we need x minus and x minus. Yeah.
How do you tell if you're supposed to factor it or use the plug that in formula?
So that part just comes from experience, because when I look at this in my head quickly, I'm thinking 2 numbers that multiply to give me 6 and add to give me 5. Yeah, 3 and 2.
So I can just try this, and if it doesn't work.
Right, you could just try it. Like if this was a 6 and this was like a 10, I'd think 2 numbers that multiply to give me 6 and add to give me 10. Not going to happen. Can't get that. All right, so now what you do is you have to figure out what the last 2 numbers are. They need to multiply to give you 6. So if you want, off to the side, make a chart of all the numbers that multiply to give you 6. 1 and 6, 2 and 3. In this case, we're looking for 2 numbers that multiply to give me 6, and they add to give me 5. So would that be the 1 and the 6, or the 2 and the 3? 2 and the 3. And because it's an x and a minus and an x and a minus, it doesn't matter which one you put where. If one of them is a plus and one of them is a minus, then it matters which number you put where. So 2 and 3. And now what we can do is I check it to make sure that we factored it correctly. What's x times x? I'm just going to put that off to the side. What's x times negative 3?
Negative 3x.
X times negative 2?
Negative 2x.
And negative 2 times negative 3. Negative times negative is
Positive 6.
positive. X squared minus 3 minus 2, that's minus 5. And that's exactly what we have. So we have factored it correctly. Okay. So now, to solve, set the top equal to 0. We did that. We factored it. Now, take each individual factor and set them equal to 0. Okay. How would I get x by itself on the left? Add 2. And what does that give me for an answer?
2.
2. And how would I get x by itself on the right?
Add 3.
Add 3. And that gives me x equals
3.
3. And the last thing I said to do was check it. Make sure that you can plug it back in. Let's plug in 3 and see what happens. What's 3 to the second power?
9.
9. What's 5 times 3?
15.
15. And then plus 6. And then in the bottom, 3 minus 2 is 1. Let's see what that comes out to. If we take 9 minus 15 and add 6. Okay, so now we're checking. We're done. We're checking to see if it works. I get 0 in the top. What's 0 divided by 1?
0.
0. So there you go. 3 works. Okay. So that one's good. Let's check 2. If we plug in 2, what's 2 to the second power?
4.
4. What's 5 times 2?
10.
10. And then plus 6. What's 2 minus 2?
0.
0. 4 minus 10 is negative 6 plus 6.
0.
We ended up with 0 over 0. What's that? What happens when you divide by 0?
Can't you not do that?
You can't divide by 0. So that means this answer doesn't work. We cross it out.
Is that because it, well, why, or because it equals the bottom?
Because if you plug in the number 2 into the
Yeah.
bottom, you
Yeah.
get 0 in the bottom of a fraction, and you're never allowed to have that.
Okay.
So it's 3 things that could have happened. We could have had 2 answers that worked. We could have had 2 answers that didn't. Or we could have 1 that did and 1 that didn't. And that's what happened
You said
here.
that's called an extraneous?
We did talk about that last week with extraneous. I'm not too worried about that term today because I just don't want to confuse things. But yeah, we just don't use that answer. All right. Now, to really see what it looks like, let me graph that problem. And how many times should it cross the x-axis based on the number of answers we just found?
2.
Did we find 2?
No, 1.
We only really found 1.
Wait, so you have to plug it into the top and bottom when you're checking?
Yes,
Okay.
because if it causes you to divide by 0, that's no good. So let's see, it should cross the x-axis at the 2 numbers, or the 1 number we just found. What was that number? 3. Okay. And where does it look like it crosses the x-axis?
3.
That's exactly the number we just found, 3. The other number that we found that didn't work was 2. Does it look like it crosses the x-axis at 2? No. It's because it doesn't work. So 3 is the correct answer. All right. So let me just kind of zoom out so anyone watching the video can kind of see the whole thing. Any question on that one? Okay, so that's finding roots. All right, let's try this one. So I gotta feel. Okay, so find the roots. Let me give you guys a second. Why don't you see if you can find the roots, and then I'll come and check and see what you got. So try doing the same thing on this one that we did on the last one. Okay, so this one is the same type of problem as the last one. You've got a fraction, it's equal to 0. So for a fraction to equal 0, what part of the fraction has to be 0? Just the top. So we're going to set that equal to 0. Now if we were going to try to factor that, it's a minus and a minus. What would be our signs when we try to factor if it's a minus and a minus?
Plus and a minus.
We would have to do a plus and a minus. But in this one, you're not going to be able to find numbers that work.
Yeah.
Because you'd have x and x, plus and minus. Now you need 2 numbers that multiply to give you 1, which are what?
1 and 1.
1 and 1. But the problem here is now you get minus x plus x. That doesn't give me negative 2. So this problem factoring is not going to work. So if we can't factor it, what's the name of the formula we can use? Yep. So here, I'll write down cannot factor. So use quadratic formula. Okay, up in the upper right, I put down what the formula is. Negative b plus or minus, there's two answers. Square root of b squared minus 4ac all over 2a. So we have to identify what the a, the b, and the c are. This is a. That is b. That is c. A is the number in front of x squared. B is the number in front of x. And c is the constant at the end. Okay, so let's fill that into our formula. Okay, so what's the first thing I would write down? What's negative b?
Negative 1a. Negative 2.
2.
So let's put them off to the side over here. What's
Negative 2.
what's a?
Is it just 1?
1, b,
Negative 2.
and c.
Negative 1.
Okay, so the first thing they want is negative b. So put a negative in front of that number.
So it's 2.
2. Positive 2. Negative b. Plus or minus. Now they want b squared. What's b to the second power?
1 squared.
What is it?
1 squared.
No, b is negative 2.
4.
4. 4. Minus, just a coincidence, that's also a 4. What's a?
1.
1. And what's c?
Negative 1.
Negative 1. And we have to divide that entire thing by
2 times 1.
2 times 1.
Which is 1. Wait,
No,
which is 2?
2. Okay. 2 times 1, 2.
2.
Yep. Okay, so now we got to just simplify that, and then that's our answer. So 2
Oh, wait, sweet.
plus or minus. What's 4 times 1 times negative 1?
4.
Negative 4.
Right.
Yeah.
So let's copy down that minus. 4 minus. And now let's do this part out. 4 times 1 times negative 1 is negative 4. But when you subtract a negative, what happens?
It comes up positive.
That's going to become positive. Okay? So what do we have under the square root now?
8.
2 plus or minus square root 8 over 2. And the last thing, which does come up in this one, is if you get a square root you can simplify, we need to just break it down as much as you can. It doesn't mean write a decimal. It means to reduce. How can we break up the number 8 into a product of two numbers? And one of those numbers I would like to be in this list.
4. 4 and 4.
Keep going.
4 and 2.
That was a multitude.
So we want to write 8 as something times something, and you have to pick at least one of the numbers has to be in that list.
4.
4 and,
2.
yep. So that's how you break down the square root of 8. And the reason I wanted you to break it down using a number in that list is because all these numbers have nice square roots. What's the square root of 4?
2.
2. That's how you simplify the square root of 8. Okay, so now just change the square root of 8 to what we just said it was. 2 plus or minus 2 root 2 over 2. Now look at what happened there. Everything outside the root is divisible by what?
2.
How many times does 2 go into itself?
1.
And how many times does it go into itself again?
1.
And again?
1.
So they all turn into 1s. So final answer is 1. Copy down the plus or minus. 1 times the square root of 2, you can just write square root of 2. and divided by 1, you don't have to put divided by 1 because dividing by 1 doesn't change anything. So that's the final answer. Okay, so when you have to use quadratic formula, yes, the answer will come out not as nice. Okay. You're going to end up with a square root in it. Okay, so any question on solving a quadratic with factoring and then solving a quadratic with quadratic formula?
Yeah.
So do you have to like check quadratic formula after?
No, I don't have to check that one because I can tell by looking at that, there's only one number I can't use right here. What number are you not allowed to plug in there? You can't plug in 1. And I can tell that's not the number 1. That's 1 plus the square root of 2 and 1 minus the square root of 2. So that's it. Yeah. Okay. Any other questions on that one? Okay, so the last one, finding the root, is one we're going to use the calculator.
Wait, what was this? I thought this was finding roots.
This is finding roots. Yep.
That's what we've been doing?
Yes, we're
Yeah.
doing the same type of problem again. This is the last one, I think. Yep. Okay, because this one is a, well, you tell me, what's the highest exponent of what's in the top?
3.
3. That's not the kind of problem we've been working with. We've been working with the highest exponent of 2. Quadratic. That's not quadratic. So that one's a little bit more complicated than we've learned how to solve with algebra, which is why we use the calculator. Okay. Start out the same way. You have something divided by something equals 0. If we're going to divide these two things and get 0, what does that mean the top has to be? Right. So all we're going to do is figure out where the top is 0. Okay. So let's try to do it. So no matter what I'm going to figure out on the calculator, I need to type that in first. So if you have anything in y equals, we'll just clear it out. Do I need any parentheses when I'm typing that in? No. I don't need anything fancy because there's no division here. So just type it in exactly like you see it. X cubed minus 2x squared minus 5x plus 6. And what should I use to start for my window?
6.
Yep, let's do zoom 6 and just see what that looks like. Zoom 6. Okay. We're looking for where the roots are. Where are the roots in that picture?
Because that's where it crosses the x-axis, right?
Right, that's where it crosses the x-axis.
-2 and 3.
Yeah, it might be. We don't know exactly. It looks like they're going to be nice answers. But what do we press to find them exactly?
Oh, totally.
Is it second calc?
Second calc, and then which option?
Intersects.
0.
0. Yep, we're finding the roots, which means we're finding the zeros. To do an intersect, you have to draw two things on the screen at the same time and see where they cross. We only have one thing drawn on the screen. So second calc 0. And when it says left bound, that means I'm just going to go to the left of where I think it crosses. Go to the right of where you think it is. And then for the guess doesn't matter. You can put the guess wherever you want, just between those dotted lines. And as somebody said earlier, yes, the first answer is -2. Okay, so when we start writing down our answers, we want to make a list of roots off to the side. So -2.
Wait, when I try to calculate 0,
Okay, so now how do I get the next one? What do I have to do?
Do the same thing.
I do the same thing again. Second calc, 0, except this time, move your cursor closer to the other side. To the left, to the right, do your guess, and that's what you should get for your second answer. So, I got 2 of them. Is there any question how I do the third one? Yeah. No? You just do it one more time. And sometimes the answers come out nice, sometimes they don't. Does anybody want me to do the third one?
Do you always do it left to right?
You can do it in any order you want.
Okay, because when I did it, it said error, and I don't know.
As long as when you press 0, you have to pick a point that's to the left.
Yeah.
You get a dotted line there, and to the right. So when you do this step, these little arrows that I just circled up there,
Yep.
they should be pointing at each other.
Okay, I got it.
If they're not, then something's wrong. And then the last root is at x equals 3. So it was -2, +1, +3. So -2, +1, +3. I'm just going to move all these out of the way. I'd already written one of them down. Any question on how to get those roots?
You don't have to check these either way.
No, you should make sure that they don't cause you to divide by 0, but I can tell just by looking at the bottom, if I plug in 1 squared is 1, 1 take away 3, that's not 0.
Yeah.
If I plug in 3, what's 3 to the second power? And 9 take away 3, is that 0? No.
No.
And if I plug in -2, what's -2 to the second power? 4. What's 4 take away 3? That's fine. 4 take away 3 is 1. None of those numbers cause you to divide by 0. So yes, you should always check them like I showed you, but in this case, they were all fine. If you get one that causes you to divide by 0, remember, cross it out. Okay, so that's the first topic that was on the test that I wanted to go over. Okay, finding roots. The second one is finding maximums and minimums. So just kind of a general overview before I do it. The way we do maximums and minimums is on the calculator. You don't have to do anything by hand. This is what we call a local max. This is a local min. A local max is a point that's higher than everything else around it. A local minimum is lower than everything around it. All right, so let's graph it and see if we can find any maximums or minimums. When I type this one in, do I need parentheses?
Yeah.
Yes, because it's the numerator and denominator are both complicated. So you've got to put parentheses around them. 2x squared minus 8x plus 5 divided by x minus 3. Okay, and what would be a good window to start with? Yep. Let's do zoom and press 6 and see what that looks like. Let me just check, make sure I typed in everything.
Do I need the parentheses on x minus 3?
Yeah.
Oh.
Oh, yeah. Yeah, I think I typed in everything okay. I'm just going to set my Y-max a little bit higher, just so I can see if there's anything else going on. So a local minimum or a maximum would be where the graph takes a turn. Look at that graph. Does that graph have any like turns in it? No. This, you can zoom out, but this piece is just going to keep going that way, that way, that way, and that way. This particular graph never does something like that. Okay, that's how you get a local maximum or a minimum. That's a max, that's a max, that's a min. This graph doesn't do that. So for this one, we just say none. There are no local maxes and mins, and that is possible. Okay, we will do one where there are. And if the next one doesn't work out that way, I'll fix it. So okay. Any questions on that one? There are none. All right. Let's try this one. So they've given us what? -2. You're just going to type it. You know what? I would still put parentheses around the whole thing too. So type it the way they show it to you, but also do this. Add what I just put in red. So -2 x minus 3 squared plus 12. Okay, so the top should look exactly like what I have right there. And the bottom, x minus 1. Put that over there in case people need to copy down how to do that. Okay. Take graph. Okay, so yeah, not crazy about that one. Looking at that one, are there any local minimums or maximums? No. So I'm going to make one up that does. So another one with none. So let's do this one. F of x equals type that in on y1. I guarantee you there will be minimums and maximums. Okay, and type it in just like that, just with the parentheses. X minus 3, x plus 2, x minus 1. And let's do zoom 6. Okay, so looking at that one, what do we think? Are there any local minimums or maximums? Absolutely, because the graph is changing direction. Yep. Let's start with how many local maximums are there?
One.
Just one. This right there is a local max. And how about that one? What would that one be called?
The local minimum.
That's a local minimum. The reason it's called local is because local means in that area. I'm not saying this is the minimum. This part over here goes a lot lower than that part. But in this area, local to the area, it's the lowest. Okay, so how do we find those?
Go second with the calc again.
Yep, second calc, and let's do the maximum
And then
first.
maximum.
So you press maximum. Same idea as what we did before. You've got to pick a point that's to the left. Pick a point that's to the right. Okay, the two arrows should be pointing at each other, just like that. And the last thing you need is the guess, which again, just put it as close as you can. All right. So what the calculator gives me is a coordinate. That is the coordinate for the maximum. So depending on what the question asks you, that'll control which number you write down. So this is what the max is. The maximum is 8.2. That's what it is. And this is where it is. We always describe where it is on the x-axis. So where the max is. So in other words, if you wanted to get the number 8.2 for y, you would plug in negative 0.78 for x.
So would our answer just be 8.2?
If the question was, what is the maximum value in that area, it would be what you just said, 8.2. If it said, where is the maximum, you would say it is when x is negative 0.79.
So if it said like find the local maximum and minimums, would you?
I'd be a little more specific than that. I'd either say, once you find the local minimum, tell me what it is, or tell me where it is.
Okay.
I'll use one of those two words.
Okay.
Yeah. I guess if I didn't use one of those two words and I just said find the local minimum, I would just write both.
Okay.
I'd write the whole coordinate. Yep.
Did you get points taken off for just writing both either way?
Well, if I say what the maximum is and you put both numbers, then I don't know if you really know which one it is. So, yeah. If it asks a very specific question, then you have to write the right number. Okay, how do you find the minimum?
The same way you just click minimum.
Yep, second calc, minimum. So move your cursor so you go to the left, go to the right, do your guess. Okay, let's put that one down here. Okay, so what if the question was, what is the minimum value in that area?
4.0.
That is negative 4.06. That is as low as the graph goes. So this is
What do you want us to round to 2? Or do you not want us to?
you could round to 2 decimal places. So if you did this, that's fine.
Okay.
Negative 4.06. So that's what the minimum is. And this number 2.12, what's that one? Where? That's the number that if you took 2.12 and you filled it in for all the x's, you would get negative 4.06.
Okay, so is x always going to be where it is and y is always going to be what it is?
Mhm.
Okay.
Where the minimum is. So what it is, where it is. Any question on finding the local mins and maxes? Pretty much just on the calc. Okay, so the last two things are EBM and domain. EBM, most people did good on the last test with anyway, but we'll just practice it. So EBM is when you take the highest degree term that's in the top and you take the highest degree term that's in the bottom and you divide them. EBM. You know what? Let me write it this way. So it's the highest degree. And when I say degree, does everybody know what I'm looking at? The degree is, I'm looking at the exponent. It's the highest degree term in top. When I look at this one, I've got 2x squared, 3x, and negative 1. The highest degree term in the top is 2x squared. What about the bottom?
2x squared?
Yeah, bottom, it has an x squared. What is it again?
2x squared.
4x.
I mean, oh,
4x
okay.
squared. So highest degree term in bottom. Okay, so it's 2x squared. Think of 2x squared as 2xx and 4xx. When you divide that out, what's going to cancel?
The x's.
X's cancel. And what are you left with? 2/4, which reduces to 1/2. That's how you find an EBM. So out of all the things we've done so far today, I think that's probably the easiest one. All right, let's try another one. So this one had the same amount of x's in the top and in the bottom. That's why all the x's canceled out. Okay, let's look at this one. Okay, Kyle, what's the highest degree term that's in the top there? Yes.
3x.
3x. Brett, what's the highest degree term at the bottom?
2x squared.
2x squared. What can I cancel out from the top and the bottom?
The X.
How many?
One.
Just one. There's only one to cancel from there, and there's only one to cancel from there. What does that leave me with?
3 over 2x.
Yep. And that's the EBM. Tomorrow we'll use the EBM when we talk about a horizontal asymptote, but I separated that for a different day. Okay. Questions on finding EBM? All right. So last 2 questions. Find the domain. This kind of relates to what we talked about earlier. There's only one thing you're not allowed to do in this fraction. You have to make sure that you know what, I'm going to let me change this a little bit. I'm going to keep the top the same. I just don't like the bottom. Let's do x squared plus, let's do 5x plus 6. Let's make it that. Okay, so there's only one thing that you are not allowed to do in the bottom.
Can't equal 0.
Right, the bottom cannot equal 0. So the domain is every number except ones that make the bottom 0. So let's find the ones that make it 0 and then say don't use those. Don't worry about the top. The top for domain, it's not important at all. Okay? Just make sure the bottom isn't 0. So the easiest way to do that is find out what would make it 0. Because that highest exponent is a 2. What kind of equation is that?
Quadratic.
Yep. And what's the simpler way I showed you to solve a quadratic?
Factor.
Right. Then we don't have to do all the negative b stuff. What would be your first letter in each parenthesis?
X.
X and x. Because it's a positive middle and a positive constant, your chart says plus plus. 2 numbers that multiply to give me 6 and add to give me 5. 2 and 3. Yep. So now, what number would you plug in to make x plus 2 0? Negative 2. And what number would you plug in to make x plus 3 0? Negative 3. Now remember, that's not what the domain is. That's what it isn't. It cannot be these 2 numbers. Okay? So think of those numbers on a number line. There's negative 2. Here's negative 3. Can you use numbers lower than negative 2?
Yes.
That's fine. Can you use numbers between negative 2 and negative 3?
Yeah.
That's also fine. Can you use numbers above negative 3?
Yeah.
Yes. So your domain here is going to be split into 3 sections. 1, 2, 3. How low does section 1 go? Negative infinity. And how high does it go, but it doesn't include the number?
Positive infinity. Or negative 2.
Negative 2.
Oh, okay.
That's where section 1 stops. When we have another section, what's the symbol that we put?
Greater than. Oh, no. Or.
An
The
or.
U?
The U, yeah. Okay. Look at section 2. What's the lowest that section goes?
Negative 2.
Not including it.
Yep.
And the highest?
Negative 3 not included.
Negative 3. Whoops, I think I wrote those backwards, sorry. Negative 3, negative 2. It didn't, yeah, they messed this up. So negative 3 is lower than negative 2. So always put the number on a number line that's lower to the left. Okay, so what's, now looking at the middle section again, how low does the middle section go?
To negative.
That's the lowest. And what's the highest?
-2.
Yeah, -2 is higher than -3. Or, look at the third interval. What's the lowest that that one goes? -2. And what's the highest that it goes? Goes up to infinity. And that's how you write your domain. It's pretty standard pattern. When you have two numbers that are not in the domain, you get 3 sets of parentheses. That's what always happens. Okay, any question on that? Okay, so let's do one more finding the domain, and then okay, so we just have to make sure that we never have what in the bottom?
0.
We never want to get a 0. Is there a number I could fill in that would cause the bottom to be 0?
1.
1. So we don't want to use 1. So think of it on a number line. Can we use anything lower?
Yeah.
Yes. Can you use numbers that are lower? Can you use numbers that are higher?
Yeah.
Yes. The only thing you can't use is exactly the number 1. Okay, so think that's section 1, that's section 2. This time there's only one number you can't use. That gives you
2.
2 sections. How low does section 1 go?
Negative. Infinity.
And how high does it go?
1.
1, not including it. Or, what's the lowest that section 2 goes?
1.
1, not including it.
And then infinity.
And positive infinity. Okay, so that's a review of finding the roots, the EBM, domain, and local maxes and mins. Those are called local extrema. So homework is review number 1. Okay, and that's in the folder that says right here, 4243 detailed. So it's review number 1. Okay, any questions on where to find that on Schoology?
We
Okay.
just leave that up for a second so I can